So, Matthieu,
Yes.
you're from France, right?
I'm from France, yes.
So, well, you told me something about lunch, and I checked with my friends who were also doing biking.
Oh.
So, how many kilometers have you done at once?
It was over 400 on
So
the day.
it's it's 400 kilometers
Yeah.
a day. So, who bikes? Is it a lot? Yeah, that's what I thought. It's like an enormous amount of kilometers. Impressive. And so, yeah, Belgium has a lot of bike paths, so you're welcome to come here by bike next time. And yeah, we'll see how it goes, right?
Thank you.
But for now, you're gonna talk about signals.
Yes.
Yes. Okay, so let's give Matthieu a warm welcome with a round of applause.
Perfect. So I'll start with a little story that happened this summer. I was actually with Michael and some of the guys from Pushbase, and we were having some kind of arguments of signals versus observables. So. You probably know that Michael is a huge advocate of observables. He likes it. He wrote a library called Eric's Angular, uses a lot of observables. So it's great for performance and everything. But it changes a bit how we think about apps, and signals have a different approach. So with this talk, I will talk to you about a bit of this difference and how it will a bit change how you write your apps. So, my talk is called pool-based. So, I am Matthieu Riegler. I'm a French software engineer. I'm the kind of guy that codes on the train. You see a lot of pictures on Twitter where I'm somewhere on the road coding something. I'm part of the Angular team as an open source contributor. And yeah, you can find me on every social network you might know. So, let's go back to the topic, observables. Do you know what happens when you do that? You subscribe, you have an observable, and you get something. It doesn't log synchronously, because, yeah, we know observables are asynchronous. Michael does not agree with this, but they are asynchronous. But I will show you another case. Yes. In this case, they're asynchronous. But if you do this, for example, what happens? So you have a subject, you subscribe to it, and you do next. And on the next, you will see that the logging is actually here, some kind of synchronous. Pushing something onto a pipe, if you already subscribe to it, will call the subscription synchronously before going to the next function. So here, you get first 42, and then you get the log for foobar. So observables are actually synchronous if you look it this way. So when you push something, it gets computed synchronously. Kind of weird. So I say synchronous, asynchronous, okay. Now, what was interesting is, so when I was talking to Michael about signals, he was like saying, okay, signals are asynchronous. And I didn't agree with him. I can show you something here. So I have a signal, I read it. It's the same example almost as what we had before with observables. Observables were async in this case, and here I'm just reading a signal. It's synchronous. You read it, it's synchronous, and you do not have to wait. So in this case, when you read the signals, they are synchronous. Okay. Now another case. Here are signals where you write something. So example, same case as for the observables. You have you define the signal, you have an effect where you some kind of subscribe to it, and if you set it, actually what happens, it becomes here asynchronous. So the effect will run eventually when the Angular considers it should run. So in this case here, we have something that is asynchronous. So in the end, we're in a case where signals and observables are synchronous, in the other case, they are asynchronous. So we have a pattern that is a little bit different when you think about it. So reading with signals asynchronous, but when you write to it, the subscribers, if I can call them subscribers, will be asynchronous. But with observables, when you read something, you will have to wait that it's emitted, so it is asynchronous, but when you write to it, the subscribers will execute synchronously. So this is the base of our argument on the parking lot. So somehow we agreed to disagree. Now, let's talk about a bit, it's one of my favorite topics in Angular, it's change detection. It's complex, but that's the magic behind it and how it works and how our UI updates. Basically, change detection, we have a component tree from the top. You got something that we call a tick. Every time the tick is triggered, your whole tree will be checked or not checked if you use on push. And you have cases where you can have some optimization. And if we mark something dirty, we'll only check that the dirty things that happen, for example, with the signals. So keep in mind the tree of components that get checked by Angular. That's the basic of how change detection works. And it will update your UI. So, two different ways to trigger change detection in Angular. The first one, the one that we had since the beginning, observables. And often when we have observables, we use the async pipe, or we can use the Rx push pipe that you have in Rx Angular, or the push pipe that you got in NGRX. So all the three, what they do, they subscribe to your observable in the template. So you have a subscription that happens here. An example here, that's something that you will see in a lot of apps. You have a lot of observables, you subscribe to it via a pipe here, the async pipe, to display whatever you want in your template. And here there are actually different problems when you look at it. When I say problems, it's not more like things that are interesting to notice. First thing, so like I said, the async pipe is an implicit subscription. You don't know it. It's not explicit in the sense that you don't see the subscribe, but Angular does it for you. And the second thing is, every time one of the observable emits here via the combine latest, you will get a new value. So every time we'll get a new value, like I said, because when you write something on an observable, when you push something on the pipe, you will get the execution synchronously in the template here. So if we update the two values, we'll get two execution of the combine latest and whatever there is in the pipe after this. So several execution for actually one display if we emit several values. And it can actually get worse if we have in a case where you got some streams that that doesn't emit. Imagine this doesn't, we're missing the word emit. So it doesn't emit, and what happens if you are in this case? You get a blank screen or a blank component because combine latest, in this case, waits for everyone to emit. And so we have the problem that we work with events more than states. So we are in a case where it doesn't emit. It's not that trivial to debug what's happening. And we're like, okay, not as great as we want it to be in terms of DX. So in terms of what I would call push base here, as because we push over the pipes the observables, so every time something gets sent over the pipes, it triggers all the computations synchronously. And like I said, we are working here with streams, not states, should be not states. And on every push, we trigger the computation in the subscribers, mostly the templates for us. and there is a void when nothing is emitted. That is like a side problem. But when I mean all this problem, it's only half a problem in Angular in a sense that change detection will coalesce, so we won't have, if we emit every time something, we only have one CD that would schedule and not, for example, 3 or 4 different if we have 3 observables that emit. So Angular already optimized as much as it can to do this. So basically what on push is, no, not on push, sorry, what a push-based architecture is for you. And the key is that we are driven by event emission. So one event, one computation happens synchronously. A few months back, I think it was a year back, 2023, there was one tweet about Ben Lesh, who's actually been quite vocal about this, saying that RxJS is great for events, but not so great for handling states. It's not made for state management library, but it's great for what it was designed for, handling asynchronous events. So, knowing this, how can we go towards something a bit different? And of course, it's signals. Let's go back to the sample component that we had before, async pipe, combine latest. We have our observables that we are combining to display something in our template. If we had to write this as fully signals, we can drop the async pipe. Everything is synchronous because we are reading state. For the first key, I want you to remember, if you go signal, you go for states that you read synchronously. No more events. There is always a value that you will be able to read. So here, the computed replaces the combine latest because it's able to combine states, and you create your own state as a new object, and this is displayed then in the template. The idea behind signals is that we create what we call a reactive tree. So in a reactive tree, you can have what we call producer. Producer, like signals, they are the creators of the reactivity. They emit something. They have a value, but when the value is changed, they say, OK, I'm dirty, and it will propagate down the tree. So here, in this case, imagine, like I said, the signals on the top are pure producers. They will emit some dirtiness when they are changed. And this dirtiness will be somehow kept by the computed downstream. And this computed is a consumer of the reactivity produced by the first signals, but also a producer of the following consumers. So here we have really a tree of, at the top, producers, in the middle, consumers that are also producers, and at the bottom, consumers. So in Angular, we consider 2 types of consumers. We have the template that are listening, so consuming the signals, so they know when a template is dirty, so something has changed because a signal has changed, or in the case of an effect, which will tell you when a signal has been changed, and you can do some asynchronous task with it. So producer, consumers, with signals. Signals brings also something really interesting and what we call a glitch-free reactivity. So when we update a state, we sometimes update different values, but we want to have a notification that everything has changed at once. We don't want to have a partial update saying, okay, at this point, only one of my 2 signals has been updated. We want everything to be, let's say, we are in a state where everything has been updated and you can read everything at once. And this is what the reactivity in Angular provides. So in this case here, if I have 2 signals, I try to log my signals in an effect. And if I update in 1, 2, 3 times for the first one, and 1 and 2 in the second times, what will happen? You get only 1 log in this case because of the asynchronous aspect of the reactivity. So here, sending a value doesn't trigger something synchronously. It will wait for an amount in time that is determined by the framework itself, when it will say, okay, everything has been updated, you can run the computations. And this, you can see here, that it means that we will drive the consumption and will drive the computations asynchronously when it's considered to be the best time. Like I said, a single log. So it's all about the state. In our components, we will now read states and not anymore events. Simple component, two signals, one that is just a simple signal coming from a service, one that is computed. So here we have the template consuming the signals, and Angular will know when those have been updated, it will tell the framework, hey, this component is dirty, you refresh it, and your UI will be up to date. Behind this, there is some kind of discussion about how we think about our apps and how we think about how framework behave. And this is something that has been more discussed in the React community for several years, and we're also having it right now in the Angular community. So Pavel is one of the members of the Angular team, and we're thinking recently, as you can see, early November of this year, that about constructing UI, you can see it really as a function. So you have a state, and what the framework does, it will execute a function depending on the state and will produce your UI. And this is the way we think more and more today on how the framework should work. So you have a state, and every time that the framework considers it needs to update itself, it needs to produce a new UI for you to update your frames, it will execute the function depending on the state. The states may be just a state, but you can see it also probably as reducing events. So your different events that will happen every click, every async calls over the network, they will give you results. And if you put all the results together, like in a reduce function, it will produce a unique state. And this is what the framework will read, will execute as a parameter of the function to produce your UI. Here, they gave a second example. Either you could say a reduce or event or whatever function actually that it's able to integrate all the events into something that will produce a state that will be given to the function. So, that being said, UI is a function of the state. But how do we produce that state, actually? For those who will check my slides, they're already published on my site. I put a small link that's really interesting on what could be considered a state. The guy that wrote this article just puts a list long like this on what could be considered a state. Really interesting read on what you could consider as part of your application state. But now let's go back to how we produce those states. The building bricks are signals. You just say, so you have a signal that creates your reactivity, and how can we build from this? Imagine you want to say, every time the signal change, you want to update something, you reach out for the effect. It's great because when we think about reactivity, you say, okay, something changed, I want to act on it because that's how our minds work. We want to act on value changes. For example, if my signal changed, I want to update another value, I want to do a request, etc. So we reach for effect. That's how our mind works. But when you start writing your code with effects, and when you start reading your code, you lose the semantics behind it. You just see, okay, there is something asynchronous happening, but you lose the concept of state, really. You just say, okay, this is something, I will have a function that will be called on update, but you lose a semantic here. And what's interesting is when you start, first, so about the effect, like I said, it feels natural at first glance, but actually isn't. I think about it, it isn't when you actually read your code or the code you wrote 6 months ago. You forget what it actually does and you lose the semantics. So it's actually harder to maintain. It's imperative and also it should be a last resort, and I'll show you why after this. So the effect, how you link reactive things, the effect should be used. I'm not saying we shouldn't use effect at all, but it should be kept only as a last resort when there are no other solutions, and should be mostly used when you want to link the reactivity that comes from the signal to something that is not reactive. Imagining having to update the DOM, for example, with some DOM APIs, you would do it with an effect because you're waiting for value to change and you go out of the reactivity system that is provided by Angular and its signals. So if we don't want to do effects, what are the alternatives? And first alternative that we talk a lot about, it's what we call state derivation. The state derivation, sorry, is when you have a value, it's a declarative approach that will allow you to define a state. So we are back to defining state instead of defining imperative code with effect. And we call it derivation because we create relationships between different origins, source of information. And in Angular, we have a synchronous state derivation. You probably know where I'm going, with computed. So with a computed, you can just say, hey, I have a parent signal, or maybe two, and from this, I'm create a new state. So here, something declarative, I just create a new state that depends on others, and will be updated every time one or the two signals are dirty. In V19 that we released 2 weeks ago, we introduced a linked signal. That's something that, that a lot of people, a lot of developers in the community were looking for. They wanted to have something that is writable, but also depending on another source. So the difference really between a computed and a linked signal, the computed is not writable, you just read the value, and the linked signal, you can consider it more like a local state for your component. The example that we like to give, you give it, for example, your input from your component. So the input is read-only, you cannot write on it, but you want to have a local state. Imagining you have a component with a drop-down list, and you want to be able to select manually in the component. When you select something, you set the state itself. But if the state changes from the input, you want to do some computations, and everything should be linked into something declarative. And this is what the linked signal will do for you. So in those two cases, we have synchronous state derivation, so everything happens synchronously. When I say synchronously, it's about the computation. Here, when you read it, it's synchronous. But what happens if we want to have some async calls, like network calls, like HTTP calls? We need some asynchronous state derivation. So something that gives us a state, but also depends on something that will not answer synchronously. How we do it? What's the pattern behind this? This is what we call the resource pattern. So basically what you do, you create a request and a loader. The request is just your parameters, and the loader is the actual request you do to your backend, to your service, anything that is asynchronous. And the object you get back is a state that has some kind of status. That could be idle, loading, finished, or error. So you just know that in your state there is a value depending on the state itself. And you will have your UI, for example, showing your spinner if it's loading, but if you have the result, it will show it on your component. So here we have a state that represents asynchronous values, and that you will be able to use. So this one was also introduced in V19, is still pretty experimental. So what you see here might be updated in the next future. You can expect also an RFC early next year on that topic. So if you want to use it, try it. That'd be great, and provide some valuable feedback to the team so we can improve and build on this and provide something awesome for the next versions. So state derivation, synchronous or asynchronous. But back to our tree, imagine we have something like this. We have a component with inputs, a link signal inside it. We depend also on a resource, and we have a computed on it, and it's consumed by our template. So real reactivity tree that could happen in every app. And what does it mean? So, like I said, with signals, with the reactivity trees, that the signals are consumed only when the components refreshes. So here with the tree, the consumption and the computations are driven by the consumers with one M. They are driven by the consumers, so it means that it will be the framework that determines when you want to do the computations to run it only when you need it. So by running our framework, like I said, with the function, the UI is a function of the state. It's when we know that we need to update the UI that we will call the state and we will compute everything when it's actually needed and not too many times. So only dirty signals will be reread and recomputed. So it means that everything that didn't change is just memorized and you will just read it. So no recomputation means you will only compute what needs to be because of the dirtiness that is kept tracking by the signals themselves. And of course, Angular schedules when the UI needs to be updated. Mainly what happens is that when a bunch of signals get dirty, there is some kind of inner timer that is based on a set timeout and on request animation frame, whatever fires first. And when this happens, a bunch of signals has been updated, Angular knows which component has been made dirty, and only those will be updated, running only the code that needs to be run. So with this approach, we get the best performance possible by just saying we update, we run only what needs to be run. And this is, for me, what I would call a pool-based approach. So driven by consumers and only doing the computations that are necessary. Thank you very much. And like I said, my slides are available on my site.
So thank you, Matthieu.